Okay, class. Over the next few classes, we're going to be reviewing your skills that you've already learned with regards to factoring. So I'm going to be reviewing lots of topics that you've seen before. So to start off with, just want to remind you that a polynomial has some descriptors that we use to describe it. One is the number of terms. This example here has 1, 2, 3, 4 terms. 1, 2, 3, 4. The degree is the highest exponent of any term. The leading term, LT, is the first term when ordered from highest degree to lowest degree. The leading coefficient is the number in front of that, and the constant term is the last number that does not have a variable with it, which is -2. Some things that you've talked about before with regards to these and graphing is starting and ending quadrants, behavior of zeros if you can factor it, and then lastly, the constant is always your y-intercept because x is 0. You've also know how to factor numbers. And we're going to be talking about different groups of numbers. So just to review, if we factor 20 over the set of integers, that could be 4 times 5, 10 times 1, -1 times 20. Those are, or minus 20, I guess, those are all integers. If we go over positive integers, that means we can't use negatives, and positive odd, we'd have to use odd. So for instance, 13 and 3 is 39. If I want to factor over prime numbers, 180 is 9 times 20. So that would be 180 as a product of prime numbers. What we're going to focus on, though, are the difference between having rational coefficients and irrational. So in other words, irrational meaning roots, rational meaning not roots. And that is determined by the group in which we can factor, or the group of numbers that we are going to factor over. And we have two different groups here. One is over Q, one is over R. I'm just going to grab my floating tools here. Where are they? Strange, I can't see them. All right, here they are. Okay, good to go now. Anyways, over Q is rational, and over R, which is the real numbers, means irrational. So in other words, we could have roots if we factor over R, but over Q we would not. So for instance, to factor this, 4x squared minus 81 over Q, we would need rational coefficients. It's a difference of squares. There's your answer. Here, if we are factoring over Q, I can't do it because it's not a difference of squares, it's prime. There's a plus in between. I can't think of any two factors that are going to multiply to equal 16a squared plus 1. If we look at C, it's another difference of squares. We're going to have two sets of brackets, the square root of our first term, and then plus or minus the square root of our second term. Should all be reviewed for you. And here in the brackets, you can simplify. -3 plus 5 is 2, and -3 minus 5 is -8. So factoring. Now that is what we've done before. What we haven't done is, well, what about if you had roots allowed? And x squared minus 3, initially you say, well, that's not a difference of squares. And I would argue, yeah, it is. Because 3 can be written as the square root of 3. So it is a difference of squares. Same thing with part B here. I'm running out of space. I'll just go down here. The square root of 12. And maybe some of you have your little math alarm bells going off in your head. Wait a second, that root 12 can be simplified. Yes, it can. The square root of 12 is 2 root 3 because it's 4 times 3, and you would reduce that to its lowest terms. Similarly here, we can factor it, first of all, over Q or over rational numbers, but then we can take this factor and take it one step further. Now, generally speaking, we stop at one root. We wouldn't go the square root of the square root of. We stop when x is x, even though we could technically take it to the square root of x minus the square root of 2, and so forth. It's not required nor expected to stop when you get to the variable having a degree of 1. You should also be able to factor if you know the zeros, and a 0 is the x-intercept, the number that makes a factor 0. So if your 0 is 2/5, that means x equals 2/5. And if you subtract 2/5 from both sides, you would get that. Normally we don't write it as a fraction, though. If I times both sides by 5, we get 5x minus 2 equals 0. And so that would be your factor that you would say. That's the factor that produces a 0 of 2/5. For minus 8, the factor would be x plus 8. For 7, x minus 7. And then this one, it's probably easiest again if I show my work here. If I subtract both those numbers from both sides, we would get that being the factor that would make 2 plus the square root of 5 a 0. Quick review of the factor theorem in step 4. How do we check if something's quickly a factor? Well, we use that 0, in this case minus 2, and we replace x with minus 2 and check. Does that equal 0? Because if it is, then yes, it's a factor. If it's not equal to 0, then it's not a factor. You should also review decomposition, where if we had 15x squared minus x minus 6, multiply the two together, 6 times 15 is 90, negative 90. What are the two numbers that multiply to minus 90 and add to the middle number, which is minus 1? And you should know how to do that, as well as to use the quadratic formula to factor. And when you get to your assignment, when you have trouble, please ask. That's what I'm here for.